Okay, so this is the triangle's perimeter activity. If you have a triangle, an equilateral triangle with a side length of 1, what is the perimeter all the way around of that triangle? Okay, good. The perimeter is the distance around a triangle, so the perimeter would be 3. So where we have one triangle, the perimeter is 3. And we'll keep track of this information in a table. So for our x values, we'll call that the number of triangles. And for the y values, we'll let this be the perimeters. Okay, now we're going to put another triangle with this one. Okay, so now if we look at the distance all the way around, we've got 1 here, 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 and here. Now, what is the perimeter of this shape with 2 triangles stuck together? Okay, so the perimeter here is 1, 2, 3, 4. So when we have 2 triangles stuck together, the perimeter is 4. Okay, now what if I have 3 triangles stuck together? Predict what the perimeter would be. Find that perimeter, and then continue the pattern, so on. Just keep adding triangles, squishing them together, and writing down the new perimeter. Okay, so your task is to look every time a triangle is added, what happens to the perimeter, and can you write an algebraic expression for t number of triangles? So fill out the table, several more stages till you can figure out the pattern, and then say if there are t triangles, what would that perimeter be? And after you have that expression figured out, write the equation and graph the equation. Okay, so do 3 things. Fill out the table, draw more of those triangles to find the pattern, fill out the table. Number 2, find the equation, and then graph the equation. So when you had 3 triangles set adjacent to each other, the perimeter was 5, because we have 1, 2, 3, 4, 5. If you put 4 triangles adjacent to each other, then the perimeter would have gone up to 6. 5 triangles, and the perimeter would have gone up to 7, and so on. Okay, so to figure out this pattern, let's look at the number of triangles compared to the perimeter. When you had 1 triangle, the perimeter was 3. 2 triangles, the perimeter is 4. 3 triangles, the perimeter is 5. Does anybody see a relationship between how many triangles there are in the perimeter of each stage? So if we have t triangles, there would be t plus 2 on the perimeter, because if you compare the number of triangles with the perimeter is always plus 2 from the triangles. 1 plus 2 is 3, 2 plus 4, 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2 is 6, 5 plus 2 is 7, and so on. So our equation is going to be the perimeter is always equal to the number of triangles plus 2. And if we graph that in Desmos, you can graph some of the points. So there's the point 1, 3. Here's the point 2, 4. So the perimeter equals the number of triangles plus 2.